So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 131 and in this video we continue with our array to pointer decay. And we stopped at the point in our last video where I tried to make a pointer to an array, but not the element types of an array to the full array, which is in our case this int array 2 elements here, this one. So let's create this one, and I think I made here some diagram. I recreated this diagram here because I accidentally deleted the other one, and here it is the same thing. Here we stopped at this point, and what I want to do now is I want to create an array to the full pointer, which means to the full size, which is int2, which means we have here the let me show you. I need the full length here. So from here to this one. And what was the different about this one? Because here we already created here an array, which is our database array. It has also the type int2, which is here the full size, but we have 2 elements in it. And then we learned, yes, the start element can be the same, and this one is representing just one memory address, but of course this is just the start point here, and it can contain other memory addresses here. And I think I showed this one in the last video, and now what I want to make is I create again a pointer, but not to the first element, which is this int 4. I want to create a pointer to the whole array. And how we make this and what is the difference we learn in a moment. And first let's create this one. So let's see if I made this already accidentally here. Yes, I made this already accidentally here. Let's delete this line. So pretend to be not see this line, and pretend also not see this line. All right, so first of all, how we make a pointer to an array. Here we have already a pointer to an array. This one here, that was one of our example. We created a pointer. We can see this is a pointer. Nice. We have our pointer type is int, pointer type, not the pointer type, careful. And this one, this pointer points to a int type, which means not to our array. Why not to our array? Because the array has here the type to int, but it points to the first element of our array. So you read this similar like that. And that's why we still assign here this array. And yes, it is array to pointer decay and all the stuff what I talked so far. That's the reason we can make this kind of stuff. So that's okay. I hope we understood this so far. And now I want to make a pointer to the full array, which means I'm not interested in pointing to one of this type here. I'm interested to pointing to this array, which means I have a type of int2 array which has 8 bytes long. Here in my diagram, I want not pointing here to the special first type. I want to point it to the full size here. And let's do this. Let's create it. So again, what I need to know when I point to this array, of course you need to know the type, which is this one here. So we have to create a pointer for this type, and now we learn how to create this. First of all, it says int, all right, and then we have already this squares 2, okay. And now how we make this declarator, I mean the variable name here in this case. And we learned this one already, actually, here on top. It says here, and this one is exactly that. What we are going to do is this line here. If it says here any valid declarator, and we are creating our valid declarator in a moment, can be placed here in front, but it says here, but if it begins with an asterisk or a reference, so you can see it's not only a pointer, we can make also a reference or an R reference, then we have to use what? It says here, then we have to use this parenthesis. All right, so we learned now the difference about this pointer and the pointer which we want to create, because I want point to this array what I have here. And what I have to do is the pointer, which is this one here, this is now my pointer symbol, this asterisk. And now I need the variable name, let's say pointer to full array type. It's a very long name, but this one here, if you stop here, you make a mistake, because this one will be the same pointer like this one here, the one, because it's not similar, because here we have still this array too, but it would be a mistake because it says when we declare a pointer to an array, we have to make this parenthesis here. All right, so I make here a parenthesis. Now I have made it, and this arrow is only because I need to go on. For example, I can make this one, but we won't assign it also directly, because of course a pointer type you can assign to a null pointer. After this one you can say stop, but this one is not assigned, but you can also say here null, ptr, all the things what you can do with a pointer. I hope you know this when we learn pointer, but I want to assign it to our database, because I know I have here a database and I want assign this one to it. And how we make this? Very simple, assignment operator. And this pointer is asking for an address. Careful, that's the general pointer. Pointer is asking all time for an address. And now I need an address of a toInt. All right, and how I can get this? If you try something like that, this one, let's copy this one here, it will not work. I say you this at start. And the reason for that is this is an array, and at this place here, it worked only because of our topic of this tutorial, because there is behind the scene, where are you again? Here, this array to pointer decay, which means behind the scene this implicit conversion happens, and this array here actually will become a pointer, and that's why this works. But in general, you are doing not this one. What you are doing in general when you work with pointer, I hope you still know it when we learn pointer. If you want assign something to a pointer, I'm not talking about the pointer value. I'm talking about the pointer. Then we use all time the address of operator, because this address of operator, this ampersand, says give me your address. And it says here, give me your address of this one. This is an array address, and the array address is not this, and an array address is not later this int here. And let's check this if I'm talking crap or not. How we can check it? All time when you check something, use the debug tool here from this one. It's very simple. Just make here a dot here at the start point, press start, and this is analyzing this code a little bit for you, and that helps a lot if you don't understand it. For example, in my case, so we see it stopped here at start. It already see the type but not the values, because when I press here forward it will take also the value. So we see here it's int array toType, right? It's an array of toInts. This is the type here. I go further, I make here go to the next line, and now it says this is a test pointer, is a pointer type. Yes, that's obviously a pointer type because we made this so. Then let's go on one step further, and what we have here, and that's interesting now. Here we have to read this variable name. It says here pointer to full array. Okay, where is this? This one here, pointer to full array. It says the type is a pointer to an array of toInts. All right, is this right? Exactly, it's right. Like I said, we make a pointer. Yes, here's this asterisk, is this pointer here, and to which type? And the type is int2. It's this type here. So we are pointing not like this one here just to one int. I'm pointing indeed to an array here, and this one here, at least I defined it so. This is the definition, but we have to check this one here if we can assign it. So let's go to this database use ID with this ampersand. This is here on top. And it says, yes, I am a pointer here. And I point here to an int array2. But interesting is this is an address of operator. It's not the pointer operator. And when we learned address of operator, means also it's a reference. And reference behaves like pointers. We learned this, right? Yeah, how reference behave. They are not pointers, but they have a similar behavior. And in this case, it says I get you the address here of this array, and this one here is a type of pointer to an int2. So with other words, this one becomes also a pointer, but this time to a int2, which is similar like, yeah, I hope this makes now sense a little bit with when you read the other things too. Let's go on. What happens next? I have not talked about the values. I think they are very obviously, which means let's go fast through this one too. No, we don't need. I think the values are clear, right? So the values are in because we are just now interested in creating this pointer here. In this line we was interested, and this line created this pointer to full array size. We get I am a int2 pointer, and this one is also here you can see a pointer to int2 array like this one. They are same. That's why I can assign this one here. When we compare this one again to this other one here, they are same too. When we compare it here in our analyze tool, for example, it says here test pointer. Test pointers here is a pointer to an int. Database user ID, when you go here just database user ID, which is this one, it is not the same type. And yeah, it's irritating when you watch this one. It is not the same type like I said, but the reason for that this still works is, yes, because exactly our topic here, array to pointer decay. So this one you can't see it, and interesting, but when this one happens, it points here to the first time. Let me show something one more time. Let's see, we start fast again. We go here one more time fast. Let's skip this. I want to see here, this test pointer is a pointer. I want to see why it's not really showing this other test pointer database user ID. Okay, it's not showing. It's showing just the it's really showing just the type here of this array, but it's not showing the step between how it converts this one to a pointer to the first element here. It's not shown here. So with other words, you have to know this, and that's why we make these tutorials, that you have also a little bit knowledge, because this analyze tool, perhaps you can have here a setting which even shows the steps between, but in this case it's really not showing the steps between, which means that it's implicit conversion behind the scene. All these steps are not shown here in this debug, at least not here. Perhaps there are options, but yeah. Anyway, we know this, I hope, so far. And yeah, we created now indeed a pointer to an array. We get this one. And what we did here is, let me click this fast away, go to my diagram. And now I created an array to this full length, which is this full length here. And the question is now, wait a minute, why we need that? Actually, that's a good question, because we don't, a programmer most time don't need that. Why we don't need that? Because let's show here again why we don't need that in general. Careful, in general, but there are specific cases and special cases where you make pointer arithmetic and registries, things behind the scene, then you need it. But in general, you don't need it as a programmer. Why? Because we create, for example, an array, which is a list, and this is just a container, this array, right? And we are interested in the elements which we put in this list. So with other words, I don't care about this array so much. I want just access this anyhow, this element. And how we access it? Normally you would access it this way, which we learned, which is just use a pointer, for example, one way. The other way is just the array version. This one is the pointer version. You can make a pointer. You can assign the array to this pointer. Behind the scene, it is an implicit conversion, which means this pointer which you created points to the first element. Then you can use this pointer arithmetic to get the other elements if you want, or you say I don't use a pointer at all, just call the array version, which is just, let's say you can say database user ID, and then here get the first element and do something with this one and so on. Here you can use this one here. So, and you see, as a programmer, this int version here, what I showed you here, is not really used in this case for programming purposes, because here you would make something special. It's a very special case, and yeah, it's more for understanding purposes how this works behind the scene, and all this confusing parts with yeah, why it's made and so forth. So important is here to know, first of all, you need only this one. But the question is then why we are learning that when we don't need this. The problem is perhaps you encounter a code which is using exactly something like that, or anyone asking you what happens if you use this way and that way, and what is the difference, and you as a programmer, at least as perhaps not as a starter, but if you get better and better, you must definitely answer this question, what happens here, right? You have to understand it and say, yes, this one is just a pointer to the first element, and this one is a pointer to the full array, and this one is exactly that what we made here. And yes, so with other words, you have to distinguish this kind of stuff. It can come in codes, and you as a programmer, you should you can make use of it, depends on the use case, but in general, as a starter, it's only important that you understand and can distinguish this one, what happens here compared to this one here. And if you can do this, that's enough. And there is again something like pointer arithmetic. We have now here created a pointer to our toInt array, not to our int. And here in my diagram, I showed you a pointer arithmetic with the normal, with the first version, which is this one, because here I created a pointer. I assigned this array here. And now I have a pointer to the first array. And the reason for that is because this, like before, this array decays to a pointer. We can assign this pointer then to this pointer. And now I have exactly the pointer which this one was implicit convert, which means this pointer is pointing to the first element of this array. And now we could make this pointer arithmetic. Pointer arithmetic is just you take the pointer and make +1. And if you do this, you jump to the next address. +1 means just go to the next address. If you say +2, go to the not next to the other address, and so on. That's more or less pointer arithmetic. And here is a danger. What can happen with pointers? You probably see it already. For example, this normal pointer here, I have only 2 elements. And if you accidentally write here 3 elements, that can cause many problems, because now your pointer is accessing storage or anything which is not made for you. Also, the compiler has not allocated memory for you. Perhaps it is used by another program or another anything, and you are accessing with this pointer the other memory address, which you should not normally do. And that can cause really big bugs, and that's only because this little accidentally yes, writing the wrong number here, pointer arithmetic. And you see also the pointer has one big disadvantage. For example, if we assign this array to this pointer, we see not how many elements we can go, we see not, yes, we have loss of information. It's called, we can't see with this info alone how many elements this array has, which we are pointing to. Why we can't see this, for example, you can see this pointer is just pointing to the first element, and then you have check this pointer to which element you are pointed, to which array you are pointing, and yeah, that can cause problems. But let's continue with our example. I talk too much again. And here, our example, I created an array to the full pointer this time, which is this length. What happens if I use pointer arithmetic here? This is the last thing what I want to talk here. What happens here? Pointer arithmetic, let's do this here. As it is cout, and how we do this. First of all, pointer arithmetic means just take the array here and add a number. Let's copy this number here. I take this one, I add here 1, and not without this asterisk. And now what happens now is we can print this out. And let's make here first a new line. And what we get here is, we get here the pointer. This one will give us the address which is pointing to, and this one will point to the next address, but I think this debug is not showing this as well. We will see it. I hope we can see it. Let's make here a debug and check it if we can see it. So I press start. I'm here. At this point, this is not so important right now. I go one step further. Yeah, now here, pointer to full array. It says here pointer to full array. Right now it is pointing to this address. Let me copy this one. Can I copy this? Yeah, let's copy this one. And oops, that was not what I wanted. And let's see if I can paste this one here. So this is the address which I'm interested in. All right. And now let's go one step further. And oh no, what I meant, I don't know. Anyway, it's there. And let's see this one here, pointer to full array. I don't think it is showing it. No, it's probably not showing. This is test pointer anyway. It's not the wrong thing. I need this one here actually. This here. Let's make here fast the test case. Let's write here one more thing so I can see this one here, because I made this one here pointing to the next address, and actually I could see the output. I was wrong, sorry. I could watch here just this output here instead of this one here. Here I could see this one, and here we can see, oh no, I have deleted this one, right? Control Z, Control Z, Control Z, it's here. Okay, now we can see that this address here is now not the same address like here, because I use this pointer arithmetic, and if we calculate this right, this will plus 8 bytes here, and plus 8 bytes should be give this number here what we have here. All right, and that's a little bit complicated to see here. To make it a little bit more easy, what we can do is again go to my drawing. What I did was actually this here. I took this one here, that was this array, make here a copy, and I took this one here and I added now I made a pointer, so that was this one here. This pointer which we created is this one here. Let's copy this one here. Let's copy this one and write this one here this time. This is my pointer which I created. This pointer points now to this address, and if I use now this pointer arithmetic here, this one here, it will point to the next address, which is, when I make here +1, which is it will create here the next address. But this one is also a type of int array of 2. And this one also int array of 2. So here it will point to this address here. And in our case, this address was that what it showed there. But let's write in random numbers. It's almost the same, only the last 2 bits are here. Yes, these 2 digits here are different. Let's say here are A, F, 1, 5, and anything here 1, 1. They are different a little bit. This is the calculation, but you get the idea, right? So this pointer arithmetic is just jumping to the next address. If this is +1, if this would be +2, then it would jump here to this address from here to here. And yeah, and here you see also why this type is very important. For example, the other one here, which we created, the first one, is pointing to an int, and it's pointing here. And then if you make +1, it's pointing to the next one. And this one was confusing because, let's repeat this one again. Why was it confusing? It starts with the same memory address for the full length of 2int. And the first element starts also with the same memory address. But this first element occupies only 4 bytes, and after this one comes the second element, which is this 5, and it takes a new memory address. And the confusion part is that this memory address can exist in this one. Right? I hope you figured this out, how this works. My explanation was not that perfect and not that good. I hope you read a little bit more books in this case who tries to explain this a little bit more accurate than what I did. But the general idea is right, because we proved this here all time with checks here, and it works normally if I made not some mistakes. And yeah, I think let's go here fast to the last thing what we can see here. Yes, I skipped now this one here. You can watch this function here as well, and you will see this here. You can try out this one here where we pass an array to a function. And interesting is when you pass an array to a function which has an array reference. Careful here. What is that? Here you must be careful about when you see something with a parenthesis and this variable name and reference, because this reference is a reference to the int free type array. And that's very careful that you watch all time this out and make not this mistake. All right, I think there is so much more to talk, but I think we stop here. The only thing what I want to show you, there is one more thing what I want to show you how to read this kind of let's see, where is that? How to read this kind of difficult arrays here or something like that. How you can read this one here. How to understand this one here when you have here a pointer value and here are the asterisks and then here an array and then int. What is that? How you can read this better? And I think I found there a website. If I'm not sure, I hope I've found it anywhere. And this problem is I don't know where I put it. There was a very good website which explains how to read this kind of stuff, and I want to show you this website so you can read this one, and then when you read it you will understand it. And understand it automatically. Pointer to objects. The problem is I don't find it right now. Okay. All right, sorry. Oh, wait, perhaps this one. All right, I think I found the website. I found one website. Yes, Yes, I found it. Thanks God. This is the website. So this is the website which I found, and I will link this website here in the description, and you can read. Here, this person here showed how to read very difficult things. For example, he says, try to read this one here. And you see this one to read is very, 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 very complicated, because you have really more or less to analyze it to understand at all what this one is doing. And here is one thing which we have not discussed now, I think. Perhaps you still can, because we have not talked about this double pointers, and there is a function pointer or something like that. But that's not important, because he is explaining how to read this kind of stuff, even if you don't know it, because there is a simple rule. I show you the simple one in our case, so you can read this one here, and then you can try to read this website. I will link this one here. It's not too long, how to read very complicated things and to analyze. So what he says is, when you have something like that, then you start with the variable name, and then you read it to the right till you find a parenthesis. And if you find a parenthesis, something like that, you go back and say, this is a pointer. No, this is a variable name called pointer to full array. And then you read this pointer, and this is a pointer to full array pointer. But here is a opening parenthesis. Then you stop here again, and then it says you go to the right side till the end. For example, you have here an array. So this is up. Then he says, this is a pointer to full array pointer. So this variable name pointer to an array of 2, and then you go from here back to the start of 2 ints. And that was not very good explained, but I will link this one here. Read that, what he's doing, and this will really make it easier for you to read really difficult things. And here you can see step by step he shows you how you can read this and identify, and then even if you see something crazy like that, you will be able to read that, to understand that, and or how to solve that. And yeah, with that said, there's so much to talk to show. I still think we stop here with pointer to array decay. That was much. There are even more to talk about arrays and pointers, but yes, we stop here, and it's time for the next video where we make training, because we talk so much about theory. We have to less trained. We will train in the next video all the stuff what we talked about till now. It will be not so easy, but also not so difficult. I try to make simple things. And don't worry, we will not train something like that here, because that we will not need this this understanding how we make a pointer to a full array and then use this array type, because like I said, this is not really needed. As a programmer, you are interested, just create a container. Array is just a container which holds elements, and you are interested in the elements, and you want access just these elements. That's the key thing here. And it's more important for a programmer how to get to use to get these elements or save these elements, instead how to work with this containers and this containers type. He don't care. With other words, we will concentrate more on this one here, but of course you must understand this decay to pointer, because here the only thing which you really have to understand is this one, how this works. Why is this one possible to assign to a pointer, and how to work then with a pointer with this elements array. And this kind, the second kind here with pointer arithmetic, full pointer type, pointer type to arrays. This is a little more advanced, but good to know. If you really know this, is very important for cases when you encounter that you don't know where you might need this, and then it would be nice as a starter. don't worry, you probably won't need it, but as an intermediate and a professional, definitely you need to know this in the future. Because, yeah, professional must know even really crazy things, but intermediate also should know something like that. As a starter, don't worry if you have understood nothing. If you make mistakes, that was anyway optional here, this video and the other video before as well. The only real thing is probably you should know the first line here, how to use these two lines and make use it and understand this kind of stuff. With that said, I stop. In the next video, we train, because that was too much theory. We need practice to understand all this with a use case, because this was just too much talk, right? We are in a practical video and I've talked too much in a practical video. Anyway, no worry, we train this in the next, and we repeat, of course, also many things which we learned, and we combine this one now with if statements, switches, functions, we throw all together, and we will combine this and see what we can do and what not. All right, with that said, I stop here, and I will link this one here in the description. Read this website if you are interested, how to solve very big problems. I think he made a good job to explain this very nicely. It is just a helper, right? Yeah. And with that said, if you have any questions, any complaints, any suggestions, tips and tricks, write them down in the comments. Can help me, can help all. And yeah, see you in the next video where we go for practice. Good luck, have fun, and don't worry if you don't understand it so much. That was just additional material, and bye.